Assalamu alaikum. Hello everyone and welcome to this new video. Today we are gonna explore a section from a second chapter of applied topography, focusing on coordinate and surface calculations. Before we begin today's section, it's a good idea to revisit the mind map, which outlines the key concepts and structure of the course. As you know, this course has several important objectives, and in this video, we are gonna focus on just one part of it. Now, we are gonna talk about the course plan. Before we begin exploring the detail of horse circle bearing, let's quickly place it in context within the course. This topic is part of Chapter 2, Coordinate and Surface Calculations, which covers essential concepts such as the planar representation of the Earth's surface, reference axes, and orientations. The fourth section, which we're focusing on today, deal with horse circle bearing (WCB), also known as logisme in French. This concept plays a very important role in determining directions and positions in topography surveying. Throughout this part, we are gonna go through 4 key subtopics that will help us understand how to calculate bearings and use them to determine coordinates. So let's start with the definition of the horse circle bearing. What is horse circle bearing? It's simply an angle from north clockwise towards line AB between the two known stations. So this is the angle that I have just mentioned, which is the horse circle bearing. So again, this is north direction, so angle from north clockwise towards line AB. So this is the horse circle bearing of line AB. So you need to apply this definition always when you hear the same horse circle bearing. And when we talk about the bearing between two directions, let's apply this definition on the horse circle bearing of BA, which is called back bearing. As well, if this is the north, let's apply the definition from north clockwise towards line now BA, as you know, which is called back bearing. This is the horse circle bearing of BA. The next slide talking about the relationship between the horse circle bearing of AB and the horse circle bearing of BA. From the side figure, when we extend the line AB, as you know from mathematics, we will get exactly the same angle of AB. These are corresponding angles, so they will have the same value. So this is the horse circle bearing of AB. Now, our aim is the horse circle bearing of BA, which is a back bearing. So in this case, you will notice that the value of the horse circle bearing of BA, the back bearing, as we know, is the horse circle bearing of AB plus 180 degrees or 200 grads. So this is the relationship between the horse circle bearing of AB and the horse circle bearing of BA. In addition, the example given below illustrates the relationship between them. Next, we are going to talk about how to calculate the bearing. I summarize the procedure for calculating the horse circle bearing of AB and the back bearing, which is of BA, in the following steps. There are very simple steps. I will explain them in details now. Let's start with the first step to calculate the horse circle bearing. First, we need to calculate the change in easting and change in northing. The change in easting between A and B is easting of B minus easting of A. And the change in northing delta and AB, which is the northing of B minus northing of A. The answer might be positive or negative. Here we will use the signs later on in the third step. Now, let's move to the second step, which is calculating the quadrant bearing value. The quadrant bearing of AB, which is very simple, using this relation. Here, the quadrant bearing of AB is the inverse tangent of delta E divided by delta N. And there is an important note here, guys, which is clearly written here, need to use positive values for both delta E and delta N. You will use the absolute values for both delta. What is exactly the quadrant bearing? The quadrant bearing is an acute angle between north-south line and AB. In the third step, here we have four cases based on these signs. First case, we will look at the signs of delta E and delta N. From first step, if delta E is positive and delta N is positive, the whole circle bearing value of AB would be exactly the same value of the quadrant bearing of AB. Again, you will look at the signs of delta E and delta N if delta E is positive and delta N is negative in other cases. We can understand that from the coordinate system here, and to calculate the back bearing, the whole circle bearing of BA, you will use this very simple relation, which is the whole circle bearing of BA is the whole circle bearing of AB plus or minus 180 degrees. When we talk about the practical rule, we have the diagram on the right side. Shows the four quadrants around point A and shows the direction arrows and the corresponding position of point B in order to reinforce the orientation for north and east and so on. This rule is useful in topography, navigation, and geodesy to determine bearings based on different coordinates. The last part of our show is calculation of coordinates from a bearing. The important thing here is how to calculate xb and yb regardless of the quadrant in which point B is located. Its coordinates xb, yb can be calculated using the following formulas. Thank you for your attention.